things together. So I've just taken them off of the circle graph. If you're going to take the segments off of the circle graph or the sectors, are they mutually exclusive or not? If you're looking for the parts from the circle graph. Mutually exclusive, right? They're all individual, they're independent of each other. So selecting,
one of them says both, right? Like
unless you're adding two sections together, so you have nothing to subtract. It's what I'm saying. Mutually exclusive meaning if you're in the 5 and younger, you can't be in the 5 to 14. Under 5, you can't be in the 5 to 14. If you're older, wherever they fall, everything was mutually exclusive. So under 5 years old, you just go to that segment and 6.6%. If you want to flip it to a decimal, be my guest. They gave it to you in percents, leave them in percents. Sometimes, again, probabilities are easier to understand when you put them in percent. When we say what is the probability that someone was under 5 years old, and we say 0.066, that really doesn't mean a whole lot. If we say about 6 point, a little bit more than 6, or a little less than 6.5, a little more than 6.5, we kind of see a better percentage-wise. Randomly selecting someone who is over 45 years or older, because this is mutually exclusive, you can add the 45 to 64, the 65 to 74, and the 75 and older. Just add your percentages. It makes much more sense. Randomly selecting someone who is not 65 years old, well, if all of your circle has to add up to 100, if they're not 65 or over, you're just going to take away this 75 and this 65 to 74, add those up, and subtract it from 100. Use your complement condition, your 1 minus condition. In the case of percentages, it's 100%, not 1. And randomly selecting someone who's between 20 and 34, just add those two because they're mutually exclusive. Are we good with that? Okay. Okay, number 21. Gave you a graph to use. Okay, you had to look at the responses on the graph on the Pareto chart. Everybody recognize that as the Pareto chart from highest to lowest? And again, a Pareto chart, all the pieces are mutually exclusive. You're either in one bar or the next. Yes. No, you can. I said you can keep them in reduced fraction. You can keep them in regular fractions. Technically, you're supposed to either give me 3 decimals or give me a reduced. But I said for these, if you're going to compare things that have different denominators for the same graph or the same circle, it's very difficult. So keep them the same. Don't reduce them until you have to. And if you don't reduce them, I said I'm fine with that because otherwise you have no way to compare. In fact, this one, it's easier to compare when you look at this. You can obviously tell which one has the higher probability because your denominators are the same. So you look at your numerators. I personally like to go to the decimal because it's much easier to say this is 94.9% probable. This is 61.2%. Which one has a higher probability? I think when you look at percents, it's so much easier to understand your probabilities. And again, if you leave your answer, sometimes you do like subconsciously just do the work and put the answer down. I'm okay if you don't give me those terms because I think it's easier to compare. Randomly selecting a person who gave public schools a grade better than a D. So better than a D, they would have to have given them an A, a B, or a C. So add those together and come out with your probabilities. A D or an F, probability that it's a D or an F, you can absolutely add your D and F, or because A, B, and C, the only other options are D and F, subtract this guy from 1. Use your complement condition. Okay. And randomly selecting a person who gave it an A or a B, they're mutually exclusive, so add them together. Are we good with the mutually exclusive part? It's where they overlap that everybody usually has problems, such as the charts. Okay. Probability that the student is a male or a nursing major, go to the males, go to the nursing majors. You can clearly see the overlap. You're going to add the males to this column. You're going to add the nursing majors to this column, but you added those 94 people twice. So you're going to have to subtract it out. Okay? So subtract it out. Yeah, I like the graphs because you can kind of see them a little bit better. A student who is a female and not a nursing major, there's your non-nursing majors. Here's your females. Here's your non-nursing majors. You can clearly see this one is your overlap. So subtract it out. They all use the same denominators. A student who is not a female, well, if a student is not a female, what is it? A male. It's a male and a nurse board, and put them in a nursing major. Okay, so that's the same one as the first. You see how it's restated? It's kind of, like, really it doesn't make any sense to say not a female because there's only two options, a male, but they kind of do the not statement to just throw you off all the time. Where it really gets you is when we do the defective and not defective. Not defective means good, and of course your good should have more probability of happening than your not goods. But they love to throw in those nots in there. So kind of just break those knots down, and it's the same exact as that one was. And again, another chart. Person who wears only contacts or only glasses. These are mutually exclusive. They don't cross over. Get your only contact row, your only glasses row. Add them together. A person is a male or wears both contacts and glasses. Well, we found our both contacts and glasses in here, are both in here, and we find our male, and you can see right where they overlap. Circle your male, circle your both, and take out the part that overlaps. A person who is a female and wears neither, there's your overlap. The female on this row, the neither on this column, and there's your overlap. I like the chart so much more for you to see when something is not mutually exclusive. It's clear when it's mutually exclusive because the rows are separate, or the columns are separate, whichever way you're looking. And it's nice to see when they're not mutually exclusive because you'll see the overlap. Very similar to a Venn diagram. If you made a Venn diagram and you looked for this one, you would say a female, and then you would say in the neither column, neither glasses or, and the overlap would be right here. That would be the 681. That would overlap. Same as a Venn diagram, but they just make it on a chart. And a person who is a male and does not wear glasses, well, if they do not wear glasses, they could wear contacts, but they can't wear both. But they could wear neither. They just can't wear both because glasses are included in the both. So you have to include the contacts and the neither in that. I'll move this down. Okay? So you had to subtract out these guys where your overlap is. That was kind of unique because they gave you two things to do. Okay?